Good evening and a very warm welcome to all of you. I hope you are doing good and having a great time. So my dear students, today I'm here to actually let you know that how the entire team is going to teach you in the brand new Phoenix 2.0 batch, which is going to start on 20th of this May, on 20th of this month. Well, my dear students, in this batch, we are going to teach you everything from basics to brilliance, from scratch to advance. So, for joining the batch, the enrollment link is available in the description below. So, just click that link and enroll yourself as soon as possible. So, before we move ahead, let me know in the chats if I am audible and visible to each and everyone. Let me know in the chats quickly if I am audible and visible to each and everyone. Let me know in the chats quickly if I am audible and visible to each and everyone. Let me know quickly. Let me know quickly. So, if I am audible and visible to each and everyone, let me know quickly in the chats. Come on, my dear lovely students. If everything is perfect, let me know. Let me know quickly. So, my dear lovely students, I think we are live now. So, let's begin with how actually we are going to teach you in Phoenix 2.0 batch and how we are going to teach you every single topic. So let's begin without wasting time. First of all, my dear lovely students, I have already told you that we are going to start everything. We will teach everything, but from basics to brilliance, from scratch to advance. So let's start basics of organic chemistry and let's start first thing, that is formal charge. Let's start first, and that is formal charge. Let's know something, how to calculate formal charge basically. Have a look. So this is our topic and topic is formal charge. Now listen carefully. My dear lovely students, what is formal charge? Let me write down over here. Formal charge means hypothetical charge. Hypothetical charge assigned to an atom. Assigned to an atom in a species. Assuming that electrons in all chemical bonds are shared equally, regardless of their electronegativities. Now, what is this formal charge? It's a hypothetical charge. It's not the actual charge. It's the hypothetical charge of any atom. But it is hypothetical charge assigned to an atom only and only if we assume that all electrons in a chemical bond, that means we know in a chemical bond, if bond is only one, we know one bond is made up of two electrons. That means we have to assume that in one bond, both the electrons are shared equally between the atoms. That electrons in all chemical bonds are shared equally between the atoms. You can write down over here, between the atoms. Electrons are shared equally between the atoms, regardless of their electronegativities. Now, look towards these examples, because with the help of these examples, we can understand how to calculate formal charge of different atoms. Have a look. For example, let us take an example here like this. Let's take an example of CH3. Let us take an example of CH3 in which we want to calculate formal charge of this carbon. But my dear students, first of all, you must know, if elements are present in neutral state, for example, hydrogen is present in neutral state, then it contains one electron in its outermost shell. That means number of electrons present in neutral hydrogen is always 1 if we talk about its valence electrons, or electrons present in its valence shell or outermost shell. Similarly, if we talk about boron contains 3 electrons in its valence shell or in its outermost shell if we talk about neutral atom of boron. Similarly, if we talk about carbon contains 4 electrons in its valence shell or in its outermost shell. Similarly, my dear lovely students, nitrogen contains 5 electrons. Similarly, oxygen contains 6 electrons and fluorine contains 7 electrons. Similarly, phosphorus contains 5 electrons, sulfur contains 6 electrons, chlorine contains 7 electrons, bromine contains 7 electrons, and iodine also contains 7 electrons. So these are the atoms which are generally used in organic chemistry. So remember, if these atoms are present in neutral state, at that time they contain maximum number of electrons in its outermost shell, like 1, 3, 4, 5, 6 and 7. Hydrogen contains 1, boron contains 3, carbon contains 4, nitrogen contains 5, phosphorus contains 5, oxygen and sulfur contains 6 and 6 electrons each. Fluorine contains 7, chlorine contains 7, bromine contains 7, iodine contains 7. But this is basically, you have to remember this, and you might be knowing this. So this is applicable only for neutral species. This is applicable if we talk about neutral species or neutral atoms. So as per neutral species of hydrogen, boron, carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, bromine, iodine is concerned, these are the number of electrons present in their outermost shell. Now have a look. We have to assume here that every bond is made up of 2 electrons and these electrons are equally shared. What does that mean? That means 1 electron is of hydrogen, 1 electron is of carbon. Similarly, in this bond, 1 electron is of carbon, 1 electron is of hydrogen. Similarly, in this bond, 1 electron is of carbon, 1 electron is of hydrogen. Now tell me, we have to calculate formal charge of carbon. Now, let me know in the chats quickly, how many electrons are there of carbon atom? How many electrons are there of carbon atom? As every bond contains 2 electrons and these electrons are equally shared between carbon and hydrogen. Now tell me, how many electrons are there of carbon? Let me know in the chats quickly. My dear lovely students. I am waiting. I will be waiting for your response. Come on, let me know in the chats how many electrons are there of carbon. In this molecule, how many electrons are there of carbon? In every bond, carbon is having 1 electron. As there are 3 bonds, carbon contains 3 electrons in this CH3 species. I'm talking about this species. This bond is having 2 electrons. 1 is of carbon, 1 is of hydrogen. I'm not talking about number of electrons of hydrogen. I'm talking about number of electrons of carbon only. Tell me, number of electrons of carbon only. I am waiting. At the rate of Alekia Yadav, exactly it's 3. Exactly it's 3. Number of electrons of carbon are 3 only. At the rate of Satyam the Great, it's not 4, beta. I'm talking about carbon. I'm talking about carbon in this species. I'm talking about carbon in this species. In this species, if we talk about this bond, one electron is of carbon, another is of hydrogen. But we have to count only electrons of carbon. So one electron is present in this bond, one electron is present in this bond, one electron is present in this bond. So this carbon contains 3 electrons only. This carbon contains 3 electrons only. But we know if carbon is neutral, at that time it should have 4 electrons. So neutral carbon must have 4 electrons, but this carbon is having only 3 electrons. What does that mean? 3 electrons, that means it is having, this carbon is having, that means this carbon is having 1 electron less, 1 electron less than neutral carbon. This carbon is having 1 electron less than neutral carbon. Neutral carbon is having 4 electrons, but this carbon is having only 3 electrons. That means this carbon is having 1 electron lesser than the neutral carbon. What does that mean? That clearly indicates this is having 1 electron lesser than neutral, means neutral carbon has basically lost 1 electron to form this one. Are you getting me? Now, if this is having lesser electron than neutral, any species having lesser electron than neutral species will be a positively charged species. So remember this carbon. So remember this carbon, as it's having 1 electron lesser than the neutral carbon, that means this will be a positively charged species. This will be a positively charged species. So this carbon is a positively charged carbon because it is having lesser number of electrons as compared to neutral carbon. Any species, remember, any species, if it is having lesser number of electrons as compared to neutral species in its outermost shell, that species is simply a positively charged species. And if any species is having more number of electrons than neutral species in its outermost shell, at that time that species will be having a negatively charged species. So this is a positively charged species. Now the question is, how many electrons are less in this carbon as compared to neutral carbon? It is 1. That is why, my dear lovely students, that is why I will simply say formal charge of this is +1. Why plus? Because it is having lesser number of electrons as compared to neutral species. Why only 1? Because it is having 1 electron lesser. That is why this is having +1 formal charge. This is having +1 formal charge. Now tell me, is this clear to you? Now tell me, is this clear to you? Exactly at the rate of Ehsan is saying +1, Aleke Yadu is saying +1, exactly. At the rate of Cosmic is saying +1, God bless you, exactly. That means you have to compare outermost electrons of this carbon with outermost electrons of neutral species. If there is no difference, then formal charge is 0. If there is difference, like neutral is having more number of electrons as compared to this one, so this is a positively charged species. If neutral is having lesser electrons, this is having more electrons, then this is the negative charged species. Now this is clear. This is clear to you. Now after that, let me give you another example. Let me show you another example. Suppose second example is like this. Suppose second example is like this. Second example is like this. And we have to calculate formal charge of this carbon. We have to calculate formal charge of this carbon. Let me show you electrons. So here, this bond is made up of 2 electrons. This bond is made up of 2 electrons. This bond is made up of 2 electrons. And this carbon is already having these 2 electrons as well. Now, if I change the color of electrons of carbon, can I say This is electron of carbon. This is electron of carbon. This is electron of carbon. In these two electrons, one is of carbon, one is of hydrogen. This is of carbon, another is of hydrogen. This one is of carbon, another is of hydrogen. Now look towards this structure and tell me how many electrons are present. How many electrons are present in outermost shell of this carbon? Count these number of electrons. These are 1, 2. 2 are present over here. In this bond, 1 is of carbon, so I will count only 1. In this bond, 1 is of carbon, so I will count only 1. In this bond, 1 is of carbon, so I will count 1. So total number of electrons present over here are 1, 2, 3, 4, 5. As we are talking about carbon only. Now tell me, how many electrons are present in outermost shell of carbon? Exactly, you are giving me the right answer. At the rate of Alekia, exactly at the rate of Elega, at the rate of cosmic, exactly, my dear lovely students, you are telling me the right answer, that there are only 5 electrons present in outermost shell of this carbon. Exactly, there are only 5 electrons. Exactly. Now, we know, on comparing this with neutral carbon, have a look. Neutral carbon is having only 4 electrons. This is having 5 electrons. As this is having 1 electron more, this is having 1 electron more as compared to neutral carbon. So I will say formal charge of this will be obviously negative because this is having more electrons. Gain of electron has been taken place. How many gain of electrons have been taken place as compared to neutral? 1 electron is more, that means 1 electron has been gained. So its formal charge is simply -1. Its formal charge is simply -1. So am I clear till now? Am I clear till now? Exactly. Your answer is exactly correct. It's -1. Exactly. It is -1. Okay, this is clear. That is great. That is great. Now after this, let me show you another example. Let me write down another example over here. What is the formal charge? What is the formal charge? What is the formal charge of this nitrogen? What is the formal charge of this nitrogen? Now, what we have to assume? What we have to assume? We have to assume that electrons in each bond is made up of 2 electrons. Let us suppose 1 electron is of nitrogen, 1 electron is of nitrogen. In this bond, 1 electron is of nitrogen. In this bond, 1 electron is of nitrogen. Another electron is of hydrogen. Another electron is of hydrogen. Another electron is of hydrogen, because we know every bond is made up of 2 electrons. Now, you have to count number of electrons of nitrogen only. Count 1, 2, 3 and 4. So this nitrogen contains 4 electrons. This nitrogen contains 4 electrons. But we know neutral nitrogen contains 5 electrons. Now tell me, this contains 4 electrons. So this is having 1 electron lesser as compared to neutral species. Or we can say this is having 1 electron lesser than neutral species, means clearly indicates that the formal charge of this nitrogen will be simply +1. Why plus? Because electron is lesser. How many electrons are lesser as compared to neutral nitrogen? It's only 1. That's why formal charge will be +1. Now tell me quickly, is this clear? Yes, exactly, your answer is right. Your answer is right. You are giving me the right answer. Exactly. This is exactly clear. Now, after that, let me give you one more example over here. Let me give you one more example. Say for example, you are having a structure like this. Now tell me, what will be the formal charge present on? What will be the formal charge present on each atom here? On this oxygen, on this nitrogen and this oxygen. What will be the formal charge? Now listen carefully. listen carefully. We will count number of electrons on this oxygen here. How many electrons are present on this oxygen? Now, how many electrons are present on this nitrogen? You can count. And after that, how many electrons are there on this oxygen? Just count. Just count. Now, let me tell you that this oxygen contains 1, 2, 3, 4, 5, 6 electrons. That means this is having 6 electrons. What about this nitrogen? 1, 2, 3, 4. This is having 4 electrons. What about this oxygen? 1, 2, 3, 4, 5, 6, 7. This is having 7 electrons. Now compare. Now compare these electrons of oxygen with neutral oxygen. Have a look. Neutral oxygen is having 6 electrons. This is also having 6 electrons. That means neither gain of electron has been taken place nor loss of electron has been taken place. That clearly indicates its formal charge is 0. Its formal charge is 0. So formal charge of this oxygen is 0. What about this oxygen? This is having 7 electrons. Neutral oxygen is having 6 electrons. That means as compared to neutral oxygen, 1 electron has been gained. So we can simply say formal charge of this oxygen is -1, as 1 electron has been gained. So its formal charge is -1. What about this nitrogen? Nitrogen is having 5 electrons. Have a look. Nitrogen is having 5 electrons in its outermost shell, but here are only 4 electrons. So 1 electron has been lost. So as 1 electron has been lost, so we can simply say formal charge of this nitrogen is +1. So formal charge of this nitrogen is +1. I hope this is clear. I hope this is clear. Now after that, let me show you another example. If you are having a species like this, if you are having a species like this, then what will be the formal charge on each oxygen atoms? Let me know in the chats. I will be waiting for the answer. Let me know in the chats. I will be waiting for the answer. You have to calculate formal charge on each oxygen atom. On this oxygen atom, on this oxygen atom, and on this oxygen atom. I will be waiting for your answer. Come on. Let me know quickly. Let me know quickly what will be the answer. Come on. Come on, let me know quickly. Let me know quickly. So, at the rate of Alakia Yadav is giving me the answer. Now, have a look. Let's calculate number of electrons of oxygen over here. This oxygen is having 6 electrons. After that, this oxygen is having 1, 2, 3, 4, and 5 electrons. After that, this oxygen is having 1, 2, 3, 4, 5, 6, and 7 electrons. Now have a look, have a look, have a look. So can I say this oxygen is having 6 electrons? This oxygen is having 5 electrons. This oxygen is having 7 electrons. Now compare these electrons with neutral oxygen. Have a look. Neutral oxygen is having 6 electrons. Now compare this oxygen with neutral. Neither electron has been gained nor lost. That means its formal charge of this oxygen will be simply 0. So this is having a 0 formal charge. This oxygen is having 5 electrons. That means this is having 1 electron less as compared to neutral oxygen. That means this is having a formal charge. This is having a formal charge equal to +1. As this is having only what we call 5 electrons. So its formal charge will be +1. So its formal charge will be +1. Why? Because this was having only 5 electrons. That means this is having 1 electron lesser as compared to neutral oxygen. What about this? This is having 1 electron more than neutral. That means it is having -1 charge. It's having -1 charge as 1 electron has been gained. I hope this is clear to each and everyone. And this is the example which was asked in NEET 2026 examination. This is an example which was asked in NEET 2026 examination. A very, very, very simple exam. If you are very much sincere towards studies, if you are very much dedicated, if you remember each and everything what teacher teaches, then it is very easy to crack this exam. Otherwise, this exam is a very difficult exam. Am I clear till now? Let me know in the chats quickly. Let me know in the chats quickly. Am I clear till now? At the rate of Arun Kumar, beta, I will let you know how to master the organic chemistry. I will form a video for that, definitely. And there is how organic chemistry is related to chemical bonding. Chemical bonding is very, very, very important. Not only chemical bonding, I will tell you each and everything in that video. I will form a video for you people, definitely. Now, after that, after this, let us begin with this. How to calculate, how to find number of sigma and pi bonds. Now have a look. How to find number of sigma and pi bonds. But before that, let me tell you, if you have a single bond between two atoms, suppose two atoms are A and A, and there is only one bond between A and A, or there is a bond between two different atoms, but there is only one bond. Whenever there is only one bond, we call that bond as a single bond known as sigma bond. You know that because you have studied this in chemical bonding. Similarly, this is also a single bond, so we can call this as a sigma bond. Similarly, my dear lovely students, if you are having more than one bond between two atoms, then one is what we call a sigma bond and another is a pi bond. So one is sigma and another is a pi bond. Similarly, if there are two bonds between two atoms A and B, one is obviously sigma bond and another one will be a pi bond. Another one will be a pi bond. Similarly, my dear students, if you are having more than two bonds between two atoms, one is sigma. So there is one sigma bond and rest of the bonds between these two atoms are pi bonds. That means these are two pi bonds. So one is sigma and pi bonds are 2 in number in this case. Similarly, if you are having more than two bonds between A and B, only one is sigma. So here it is one sigma and the rest of the bonds between two atoms will be pi bonds. That means there are two pi bonds and one sigma bond. So this is very, very easy. For example, let me give you an example like this. You have to calculate number of sigma bonds and number of pi bonds. You have to calculate number of sigma bonds and number of pi bonds. And suppose you have to calculate number of sigma and pi bonds in number 1 in this structure. Now, tell me how many sigma and how many pi bonds are there. Let me know in the chats. How many sigma and how many pi bonds are there in this molecule whose formula is C2H4. Let me know quickly. Beta, what is a coordinate bond? And is there any coordinate bond between nitrogen and oxygen? You should know this because this is very, very, very basic. whenever you know there is a bond formed between two atoms in such a way that both those electrons are basically of only one atom, but that atom is giving one electron to another atom, and after that it is undergoing mutual, say sharing after that by donating first, after that mutual sharing. That bond is known as coordinate bond. That bond is also known as dative bond. Yes, so there is a dative or a coordinate bond. Now everyone is giving me the answer. That is great, because this is very, very easy. Have a look. As there is only one bond between C and H, so this is a sigma bond. So similarly, this is a sigma bond. Only one bond is present between two atoms, means it's a sigma bond. But if there are two bonds between two atoms, one is sigma, another is pi. So can I simply say here are 1, 2, 3, 4, 5 sigma bonds are there and one pi bond is there. So there are 5 sigma bonds and one pi bond. After that, how many sigma bonds are there in this compound and how many pi bonds are there in this compound? How many sigma and pi bonds are present in this compound? Let me know quickly. Very, very, very easy. Definitely, I will make a video. Surely, I will make a video how to master your organic chemistry. Definitely, I will make a video for you people. Don't worry. Now, everyone is giving me the answer. Great. God bless you all. So, first of all, whenever there is only one bond between two atoms, so that will be always a sigma. This is always a sigma. But here, between these two atoms, there are 3 bonds. One is sigma. Other 2 are pi bonds. So this is pi, this is pi. Now count how many sigma? 3 sigma. 3 sigma and 2 pi bonds are there. 3 sigma and 2 pi bonds are there. Because we have promised you that we are going to start from basics. So this is all basic. Now, after that, now tell me, my dear students, how many sigma and how many pi bonds are there? How many sigma and how many pi bonds are there? Quickly. Very, very, very easy. Quickly. Come on. Let me know the answer quickly. How many sigma and how many pi bonds are there in this CH4 molecule, methane molecule? How many sigma and how many pi bonds are there? Exactly. Very good. Right answer. Simple answer. Nice. So these two, carbon and hydrogen, are having only one bond. That means this is sigma. This is having only one bond. That means this is sigma. This is having only one bond. That means this is sigma. This is sigma. So can I say here are 4 sigma bonds and there is no pi bond. No pi bond. 4 sigma bonds, but there is no pi bond at all. There is no pi bond at all. After that, can anyone answer this question? How many sigma and how many pi bonds are there in this, what we call ammonia molecule? How many sigma bonds are there and how many pi bonds are there? This is sigma, this is sigma, this is sigma. So there are 3 sigma bonds, but there is no pi bond. No pi bond. No pi bond. No pi bond. 3 sigma bonds, but there is no pi bond. Now, tell me, can I say there are electrons which take part in bonding? There are 2 electrons between this carbon and hydrogen, and both electrons are bonding electrons because they take part in bonding. So these are bonding electrons, these are bonding electrons, these are bonding electrons, bonding electrons, bonding electrons, bonding electrons. That means there are no non-bonding electron in case of C2H4. Similarly, in case of C2H2, there are no non-bonding electrons because all electrons are there and they take part in bonding, hence they are bonding electrons. Here, all electrons are bonding electrons. So can I say 2, 4, 6, 8, 10, 12. Here, 12 electrons are bonding electrons. 12 electrons are bonding electrons. Or we can simply say 6 pair of electrons are 6 because 12 electron means 6 pair of electrons. So 6 pair of electrons are bonding electrons. 6 pair of electrons are bonding electrons in this case. How many electrons are bonding electrons in this case? 2, 4, 6, 8, 10. 5 bond means 10 electrons. So can I say 10 electrons are bonding? 10 electrons are, we can say 5 pair of electrons. 10 electrons, or we can say 5 pair of electrons are bonding electrons. These are bonding electrons. How many bonding electrons are there in this methane? Let me know in the chat. Let me know in the chats quickly. How many bonding electrons are there in this? Let me know quickly. Let me know quickly. How many bonding electrons are present in methane molecule? Let me know quickly. I'm waiting for your reply. Let me know quickly. In methane, how many bonding electrons are there? Exactly, there are 4 pair of bonding electrons, or there are 8 bonding electrons. So can I say here are 8 bonding, or I mean say 8 electrons. 8 electrons, or I mean say 4 pair of electrons. 4 pair of electrons which are bonding. So 8 electrons or 4 pair of electrons are bonding electrons. Now tell me, how many bonding electrons are here? How many bonding electrons are here? 2, 4, 6. That means here are 6 electrons, or we can say 3 pair of electrons. 3 pair of electrons which are bonding electrons. Here all the electrons are bonding. No electron is non-bonding. No electron is non-bonding. No electron is non-bonding. But here, these 2 electrons are non-bonding electrons. That means 2 electrons are non-bonding electrons, because these are the electrons which are not taking part in bonding. So 2 electrons are non-bonding electrons, or we can say 2 electron means 1 pair. And non-bonding electron pair is known as lone pair. So I can say here is 1 lone pair of electron. What is meant by lone pair? Non-bonding electron pair means lone pair. So here 1 lone pair of electron is present, or we can say 2 electrons are non-bonding electrons, or 1 pair of electrons are non-bonding, and 1 pair of non-bonding electron means 1 lone pair. And this was also the question which was asked in NEET 2026. So have a look that few questions are very basic questions as per NEET is concerned. I hope this is clear. I hope this is clear. Now, I will write down here an example, and you have to tell me how many, this is the example number 5. Example number 5. You have to tell me how many number of sigma and pi electrons are present in this benzene or C6H6. Let me know quickly in the chats. I will be waiting. How many number of sigma and pi bonds are present in this? How many number of sigma and pi bonds are present in this structure of benzene? How many number of sigma and pi bonds are present in this structure of benzene? Quickly. Let me know quickly. Let me know quickly. We will start from basics. We will start from very scratch. I mean, say we will start from scratch to advance. We will not only teach this. We will not only teach advanced, we will teach everything from basics to, I mean say brilliance. I have already told you that. Or we will teach everything from what we call scratch to advance. Sigma bonds. How many sigma bonds and how many pi bonds? Come on. If you don't know anything about any subject, don't worry. We will going to teach you everything in Phoenix 2.0 batch. So if you have not enrolled yet, do enroll yourself as soon as possible, because there are brilliant teachers of, I mean say, India who will teach you in different batches. Now, tell me, how many sigma and how many pi bonds are there? Have a look. we can write down this structure in this fashion. Look towards the board. We can draw this in this fashion. We can draw this structure like this. This is actually the benzene. This is the actual structure of this benzene. I mean, say this is the benzene structure which is over here. This is known as the resonating structure of benzene. But what is that resonating structure? We will not go there. This is simply the structure of benzene which is over here. Now count number of sigma bonds. Have a look. This is single bond, so sigma, single bond, sigma, single bond, sigma. This is single bond, sigma. This is single bond, so this is 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 sigma. After that, among these two bonds, one is sigma, one is pi. This is sigma. This is one is sigma, another is pi. This is one sigma, another pi. So have a look. How many sigma bonds are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 sigma bonds are there, and 1, 2, and 3 pi bonds are there. So 12 sigma bonds are there and 3 pi bonds are there. And remember, all these electrons which form sigma bond and which form pi bond, all are bonding electrons. There are no non-bonding electron, or there is no lone pair of electron. Now, let me give you 2-3 examples which I would want you guys to write down the answer of those questions when this stream is ended. Once I end this stream, I would want you guys to answer those questions in the comment box, but not now, after ending this stream. So let me write down over here. Number one is, you have to tell me how many pi electrons and how many sigma electrons are there in this naphthalene molecule. Seventh is, how many sigma and how many pi electrons are there in this toluene molecule. After that, eighth one is, how many sigma and how many pi electrons are there in this benzoic acid molecule, and how many sigma and how many pi electrons are there present in this, I mean to say, formamide molecule, and how many electrons are there which are present in this aniline. How many sigma, how many pi bonds are present in this. And in addition to this, you have to tell me bonding and non-bonding electrons in 6, 7, 8, 9 and 10. So you have to tell me the answer, but after this session is ended. So this is all about, this was a very short video. This is all about that how we are going to teach, how we will teach every topic. We will teach every topic from basics to, I mean say, brilliance, and we will teach every topic from scratch to advanced level. This is all scratch, this is all basics. So I would want you guys to answer these questions once this stream is ended. But I will check one by one the answer, how many sigma and pi bonds and how many bonding and non-bonding electrons are there. I will check the comment of each and every one. So this is all for today. God bless you all, love you all, and thank you. Take care. Bye-bye.